As Dmitry had already said, my name is Konstantin, and I'm going to tell you a couple of words about Yandex ejabberd fork and what we've done to make it scalable, robust, and fault-tolerant. First of all, probably all of you know about ejabberd. Ejabberd stands for Erlang Jabber Daemon. It is an XMPP server. XMPP is an instant messaging protocol, previously known as Jabber. It is written in Erlang, and for data storage it uses Amnesia for temporary data. Amnesia also can be used for persistent data, or persistent data can be stored in ODBC database. While using ejabberd at Yandex, while we started using it, we discovered that it is too naive. When your installation includes only 2 or 3 machines and several thousand connections, everything works well. But when your installation becomes large, if you use it on tens of considered faulty machines that can fail, and you have hundreds of thousands of connections, then problems start to emerge. At Yandex, we use ejabberd as an XMPP IM server. Obviously, also we use it as a backend for our web chat at Yandex Mail. We use it as a transport for our mobile mail applications for iPhone and Android. And we use it for push notifications for Yandex Disk, our cloud file storage service. And the issues with ejabberd that we discovered are following. First, it uses direct message passing to process identifiers without any guarantees, simply using exclamation mark, which probably all of you already know. Second issue is that memory consumption of ejabberd is a bit large. I can say that it is unusable because of it, but memory footprint can be slightly less. I'll talk about that, I'll get in detail later. And it uses Amnesia-based storage, which, as I'll show, doesn't really scale. To first issue, that is message passing. In Erlang, if a remote node goes down and you try to send a message to a process that is suited on that node, that message is lost. You don't get any acknowledgement or an error on whether the message was delivered or not. The same is for local processes. If the process itself had already died, you won't receive any error or confirmation of delivery. Basically, there is no method to know whether the message was received by destination process or not. And when you use ejabberd in distributed environment, that becomes a problem. Our first thought to fix this issue was to use synchronous message passing. Send events to other processes synchronously, but after some testing and some thought, we discovered that it obviously includes receiving reply, which is, of course, another message. It is synchronous, so when you call that process, you need to wait for timeout, which is 5 seconds by default. And we decided that synchronous calls are unacceptable for this task. Our second thought was to separate the messages and bits to local, those running on the same node as the calling process, and to remote, using node function, obviously. For local messages, we check the process for aliveness, and if it is alive, we send message directly. Otherwise, we take some failover action depending on the message. And for remote nodes, we send the messages to the registered process on that node, which deals with that message accordingly. The same as with local messages. And in this scheme, those registered process, ejabberd ESM session manager, can become a bottleneck. To reduce the load on that process, we decided to separate the messages. We separated them into critical, which is message stanzas, obviously, that is messages, client messages, not Erlang messages, but IAM messages. They are critical. They must be stored in offline storage if no client is available. And we used that scheme with ejabberd ESM for message stanzas. And for IQ and presence stanzas, we used the old scheme with direct message passing. And ejabberd ESM can still become a bottleneck if message rate would increase someday in the future. Now it's not a problem for our installation, and it can be obviously fixed by setting the process high priority or replacing it with some kind of process pool. That's all about the first issue. Let's continue with memory consumption. Erlang client process, client connection process, its state consists of near 30 fields, which approximately 10 are used only during initial stream negotiation, during user connection authorization, and they are not used during process lifetime, later lifetime. That's the first issue. The second issue, that is something called subscription lists, are always stored in state, and that is pretty large data structure. And the third problem is that receiver is another process separate from C2S. That is two processes per client, and they may be joined into one. First issue is large state. We decided to fix this. We decided to split the client process into callback module. Its callback module into each with their own states. We used generic FSM for initial stream negotiation, and then we switched to generic server using generic server enter loop function. Notice the hibernate option. That gives us free bonus. Hibernate option triggers garbage collection on that process, thus reducing memory footprint slightly more. The second issue is subscription lists. Subscription lists is the data structure that stores information about contacts with which our client, our user, should exchange presence information. And there is no need for them when user doesn't send presences. We have technical connections for Yandex or mobile mail, for push notifications, and subscription lists aren't needed there. And we decided to implement the lazy retrieval. We currently retrieve them only when presence is sent by the client. Separate receiver process, it does nothing but receives TCP messages from socket. This process controls the socket and sends decoded XML messages to client process itself. That is obviously an overhead, and we decided to eliminate that process and to let C2S client process control the socket and do everything, including decoding XML and receiving those TCP messages. And after doing all that, we've discovered that our average memory consumption for one C2S connection had reduced nearly 40% to approximately half a megabyte. Let me stress that this is not about process heap or something. This is just operating system memory footprint of Erlang VM. divided by number of connections on this node. That is, it includes some port data, port drivers data. It includes some system ETS tables, I don't know. And second that we achieved here is that database load had also dropped slightly thanks to our persistent database load, thanks to that lazy retrieval of subscription lists. And that's all about memory. Now to Mnesia. Mnesia actually is a transactional database built into Erlang standard package. While using it, we discovered that as long as it's transactional, it doesn't scale after some limit, because you need to propagate all your writes to all other nodes to return from that operation. It doesn't survive brain splits, actually. After brain split, when you cluster machines due to some kind of network outage, your cluster becomes split in two. Each part, after rejoining, each part of the cluster cannot synchronize with another. Next, node deaths are fatal too. If your physical machine had failed, you cannot remove it from the scheme easily and add another, and you cannot reinstantiate those nodes on another machine if your data is lost. And basically any inconsistency in Mnesia is fatal. That's subjective. That's all subjective to Yandex. I don't know. Maybe we just cannot deal with Mnesia, but this is so. And we decided to replace it with MongoDB. Probably some of you already know MongoDB. It is key value storage with eventual consistency, with mechanisms for failover and load balancing. It heals itself after brain splits by electing the master of replica sets and replicating data using oplog. And it has, thanks to those replica sets and sharding, it has theoretical unlimited scalability. Our first try with MongoDB was in late 2010. It was Mongo version 1.2. There were still no replica sets. There was something called replica pairs involving only two nodes. And there were unstable sharding. We implemented manual sharding in Session Manager using Erlang hashing function on usernames. And we implemented replica pairs with master-to-master scheme with only one replica active at the moment. That is, all reads and writes go to only one replica, and the other is used as a failover. And we also implemented ETS caching of local sessions on each node. That scheme worked well until early 2012, when we started discovering some issues with it. Actual version of MongoDB that time was Mongo 2.0, 2.1, and we discovered that our requests per second limits per Mongo node, those master nodes in replica pair limit was reached, and master-to-master scheme has become obsolete to that moment by MongoDB developers. And we started encountering very strange replication deadlocking, which was very hard to predict and investigate the cause of it. And we decided to try replica sets to discard master-to-master replication and to try replica sets. All database requests, as we thought, they needed to retrieve always consistent data. So we thought that we cannot rely on reading from replicas and secondary replicas, and we've kept them just for failover. To this moment, Mnisia was removed completely from ejabberd. Ejabberd stopped depending on it at all. And the problem with request per second rate on master was still the same, and I started to continue to encountering requests on peaks, on load peaks. And finally, after some thought, we figured that consistent session data, user session data, is needed only in one case, while retrieving sessions of contacts to send them initial presence, and that all other cases you may have inconsistent data, and that's okay, that's completely okay. And we implemented this scheme using MongoDB slave OK version option. And after doing all this, nearly 60% of all requests go to secondary nodes. All writes obviously go to primaries with sharding. We shard on username. And this cluster, ejabberd cluster and MongoDB cluster, they both easily survive brain splits, they survive network outages, survive physical machine deaths, and massive user reconnects on network problems. And after doing all this, we see huge potential for horizontal scaling of our system. And scalability limit is actually, as I think, sky high. In case that anyone has any questions, feel free to ask. That's all with my talk. Anyone?
Why you use MongoDB if you have some problems with scaling and you actually doesn't use any transactional properties of database, why you use MongoDB instead of Erlang, for example, which would bring less impedance between systems?
You're talking about React?
Yeah.
Back in 2010, React was still not so popular, and MongoDB was gaining popularity that time. And I actually don't know why we've chosen MongoDB because we just didn't do any tests involving React and MongoDB. This is so just we've used MongoDB.
Thanks.
Erlang solutions have made a branch of ejabberd that uses only binaries, and they have gained about 30% decrease in memory usage. Do you use it? Do you use this branch?
No, we use pretty ancient fork made sometime in 2007 or 8. I don't actually remember. And I know about Erlang solutions. They used binaries instead of lists across ejabberd. No, we don't use those branch.
Hi.
Hello.
Actually, I've got two questions, one specific and one more general. So about specific question, if I got you right, when you were talking about solving the reliable message delivery problem, yes, you said that you took two different approaches, one for local messages and another one for remote. And for local messages, you first check if the target node is live, and then send a message using standard bang operation, right?
We check that process is alive, and if it is, we send using exclamation mark. We send a message.
And how is that solving? Makes your message sending reliable? Because the target node may die right after you check that it is alive.
That doesn't solve the problem completely, but it decreases chances that the message is lost. That decreases those chances.
Yes, but it doesn't solve the problem.
You cannot be sure that message was delivered unless you receive some confirmation from process, some acknowledgement, and that's cost is too much of receiving it, and you need to time out, and I don't know.
Yeah. So you allow some messages to just.
Yes, that is a trade-off between timing out and delivering.
Okay, I see.
Process.
And another question. Apparently, Yandex uses Erlang at least for one project. Yeah, but
Yes.
how this language is actually popular inside Yandex?
Sorry,
How popular this language is inside Yandex? Is it used for other projects?
While planning this conference, there was a joke. Daria came to one of our employees and said, Timson, Erlangers are coming. And Timson replied, what? All three of them? There are 3 Erlang developers at Yandex, and we use it on, I don't know, 3 projects currently. 2 projects.
So then why this event is happening here?
I don't know.
I see. Thank you.
Hello, Konstantin. Thank you for presenting us this interesting results. You know, if it's not a very big secret, what are the numbers? So what are the number nodes, and what is the number of requests per second?
Number of nodes is several tens. I cannot be more specific.
99.
Sorry. And requests per second rate on stateful system. It is almost impossible to measure that because you cannot think about a request in stateful system. There are persistent connections, yes, there are several 100,000 of them. But requests, I don't know what you can call a request in IAM server.
I see. Thank you.
Thank you.
While for синхронность, почему для того, чтобы сделать синхронную коммуникацию, вы думаете, что надо ждать тайм-аут? Не проще ли установить мониторинг этого процесса, послать ему месседж и сразу же получить, если он упал, ответ, что он упал?
Because of very large number of those monitorings, when you have some several 100,000 connections, and you send a message through client to server through session manager. A message had arrived from somewhere into session manager. That is one registered process, and you need to send that message to someone on another node. If you try to set a monitor on those nodes, that involves sending messages too. And if I recall correctly, those messages are sent using net kernel registered process of Erlang VM, which can become a bottleneck in those scheme. And I've tried that actually, and it's just fails under the load. That is all.
Еще вопросы?
Do not troll, please.
Спасибо за доклад. У меня один вопрос. В итоге все эти замечательные наработки будут где-нибудь доступны или они так и останутся в кладовых Яндекса?
Там очень много Яндекс-специфичных вещей, раскиданных по всему коду, провязанных с нашими другими сервисами. Вот. Я на самом деле, возможно, мы постараемся это все выложить, но это маловероятно достаточно.
Понятно. А я так понимаю, что вы используете какой-то старый форк?
Да, это ejabberd 1.0.
Какая версия была?
Это был, по-моему, 1.0, нет? Что-то из первых версий. Какая-то из первых.
Почему, если не секрет?
Ну, на тот момент она была актуальная, потом ее сильно переписали. Вот. И вливать просто изменения в апстриме уже было поздно.
Хорошо. Это уже так давно проект ведется, получается?
Да.
Интересно. Ладно, спасибо.